Section 2.1 looks at finding the midpoint of a line segment. Just to briefly distinguish between a line segment and a line is one that continues on forever, so there's arrows on both ends, whereas a line segment is just the piece of a line that joins 2 points on a graph. So from point A to point B would be line segment AB. So the midpoint of a line segment is the point that divides a line segment into 2 equal parts. So divides into 2 equal parts. It's halfway between the 2 endpoints. The 2 ways of determining a midpoint of a line segment are either by graphing and by looking at the coordinates on the graph, or by using a formula. And as always, the formula is the method of choice because it is the most accurate and it's the easiest one to use. So with method 1, they talk about a city having 2 hospitals that are coordinates A and B, and they want to build a new ambulance station halfway in between. So they want to find the midpoint of those 2 hospitals to figure out where that ambulance station is going to be. It's often easy to calculate midpoint when the midpoint lies exactly on the corners of the grid boxes, but in this case you can see that the middle of this line segment is nowhere near the corners of the grid boxes. So you would have to have a fractional midpoint or a decimal answer, which is difficult sometimes to calculate by using a graph. The way that you could calculate it by using the graph is by figuring out the rise and the run, and by adding half of the rise and half of the run to the original point A. So if you wanted to use the midpoint, we talk about midpoint with a capital M, small m is for slope, capital M with the subscript x comma y are the coordinates of the midpoint. And you could find it on the graph by starting with coordinates of A, so the x value for point A and the y value for point A, and adding half of the rise and half of the run. So the x coordinate talks about the run, and the y-coordinate talks about the rise. So we could add half of the rise and half of the run. In this case, we would just be calculating, we drew a right triangle there, we'd be calculating how much we have to rise up by to get from 5 to 14, which in this case is a rise of 9, and how much we need to go over to the right by to get from 3 to 11. So 3 to 11 is 8. That would be our run. If we added a half of the rise and a half of the run to our point A, we would get the midpoint of the line segment. This is not the way that we want to calculate the midpoint. It's long and it's a lot more work than what we need to be doing. The formula works a lot quicker and it's easier, and it's easier to get a quick, accurate answer. So we're not going to talk about this method 1 in detail. We're not going to use it, but it's just something that you should know, that people can calculate the midpoint by using the graph and by figuring out the rise and the run and just splitting those 2 in half. So method 2 talks about a formula. And if you think about the formula, it really comes from the idea of finding the middle between 2 numbers. If you have 2 test marks and you want to find the middle of those 2 test marks, you're going to calculate your average. So you're going to add them together and you're going to divide by 2. The formula for midpoint uses average. And so we're going to average the x coordinates and we're going to average the y coordinates of those 2 points to get the midpoint. So the midpoint, or the coordinates of the midpoint, is equal to the average of the x values, so we add them together and we divide by 2, and the average of the y values. So we add the 2 y values together and we divide by 2. Notice that it's a capital M for midpoint and that there are 2 large brackets on either side of the formula. Those brackets are necessary with a comma in between because they are the 2 coordinates of the point. So you're going to have the x value for the midpoint and the y value for the midpoint as your final answer. So let's stick our coordinates in the equation and work it out. The x coordinate for point 1, or we can call it point A if that makes life easier, if you want to think of it as A and B. The x coordinate for point A is 3, and the x coordinate for point B is 11. So we can add them together and divide by 2. And the y coordinate for point A is 5, and the y coordinate for point B is 14. So we can add those together and divide by 2. Make sure that you do include those brackets. They have to be there because it is the coordinates of the point that we're finding. So if we're going to add those 2 numbers together, we get 14 over 2 and 19 over 2. So our final answer for our midpoint would be 7, 9.5. And it's a capital M, coordinates of the midpoint. Sometimes we also see this, the capital M with midpoint of line segment AB. Just make sure that your M is a capital to distinguish from slope. Example 2 talks about the median of a triangle. So let's take a moment just to understand what that means. Median is a vocabulary word that you will need to know. It describes a line segment drawn within a triangle. And it's a line segment that starts at one of the corners or one of the vertices of the triangle. So I'm going to draw an example up here. Here's a triangle. We'll say this is vertex A, vertex B, and vertex C. So if I'm talking about a median, let's say from vertex C, just because that's the question that's coming up to us soon. We're going to start at that vertex in the triangle. So we're going to begin at vertex C. And we're going to draw a line segment, we're going to draw a median, that goes from vertex C to the very middle of the opposite side, where this is the midpoint of AB. So this line and that line segment are both the same length. The line that connects vertex C to the middle of the opposite side is called the median from vertex C. And we can have a median from any vertex in a triangle. So we can have a median from vertex A that goes from A to the middle of the opposite side. We can have a median from vertex B that goes from angle B or vertex B to the middle of its opposite side as well. So the median of a triangle is the line segment joining a vertex of a triangle to the midpoint of its opposite side. Now, with any of the questions in this entire chapter, probably one of the most important things to remember is you're always going to want to sketch a picture. It doesn't need to be a perfectly accurate graph, but it's going to be your best sketch. So you're going to have an approximate location for your points on the grid, and you're going to be able to sketch out the line you're solving for to know what to expect. Every single step of the way, you're going to want to compare your progress with the picture that you've drawn, with the sketch that you've drawn, to see if your answers make sense. Because as we continue through this unit, we're going to be solving questions that are requiring multiple steps. So we're going to be doing 6 or 7 steps to get to the answer of the question that's being asked. So it's very, very important at each stage when you find out something new that you're about to use that you check it against the picture to make sure that your answer makes sense. Because if you make a mistake at the beginning and only discover it in the very last step, you'll have to go and erase your whole question and it'll make you very frustrated. So always start with sketching a picture of the triangle. Now, I believe your page might have a grid on there, but I'm going to sketch it without one here. So when you're sketching, it just means you're going to have axes. You're going to have an X and a Y axis. They don't need to be perfect. They're going to be approximately straight lines that are perpendicular. And you're going to plot your points. So it says determine the equation for the median from vertex C of the triangle with vertices 5, 2, negative 4, 3, and 2, negative 5. So I'm going to sketch those out. I'm going to draw those vertices on my grid approximately where they would be. So let's say 5, 2, approximately over here. That's vertex C, and I'm going to put the coordinates right on there. Notice I went a little bit less than half of the width up. So if this is 5, about half would have been 2.5, so I went down a little bit lower than that. I'm going to draw negative 4, 3, so negative 4. If this over here is positive 5, I don't want to go as far as negative 5, so I'm going to sketch approximately at negative 4 and positive 3, which should be higher up than the 2 I already drew. Negative 4 and 3 is point A. And finally, 2, negative 5. I'm going to make my 2 approximately the same length as this 2 right there. So 2, negative 5 would be down there. So point B, and I've labeled the coordinates. So this is my triangle. Obviously my sketch would be even more wonderful if I had a ruler, but this iPad app does not have a ruler in there, so I'm going to do the best I can. It's the one thing it needs, that's for sure. So there's my triangle. It's just a sketch, but it'll give us an idea. And when I'm thinking about this median I'm trying to solve for, I'm going to sketch it. It's going to start at vertex C, and it's going to go across the triangle and hit the midpoint of the opposite side. So approximately there is the midpoint, and that's the median. So that red line is the median that I'm solving for the equation of from vertex C to the midpoint of the opposite side. This point right here, the red point, is the midpoint of AB. So the sketch is the first step. We have our coordinates in there. We know that they're approximately in the right spot. Second step is we want to find the things that we need to get the equation. To find any equation of any line, this is very important, I'm going to jot it down. To find an equation, we need two things. We need the slope, and we need a point. Oops. So to find the equation of any line, we need the slope and a point. So if you think about this median, this red line in my picture, how would I figure out what the slope of that median would be? Well, I don't really know what to compare it to. It's not perpendicular to anything, it's not parallel to anything, but we do have two endpoints. We have point C, and we could find the midpoint, and we could figure out the slope between those 2 points. So in order to get the slope, we need to figure first out the coordinates of that midpoint. So that's going to be our first step that we're going to do. We're going to calculate the midpoint of AB. So I'm going to write my formula down. Capital M for midpoint of AB. I'm going to include my large brackets with a comma in between. And to figure out the midpoint, I'm going to need to use the two endpoints in my formula. I'm going to use B and A to figure out the midpoint. Notice I'm using the two letters that are on the ends of the line segment. So the coordinates, the x coordinates of A and B are -4 and 2. I'm going to find the average of those two. So -4 plus 2 divided by 2. The y coordinates of points A and B are +3 and -5. So I'm going to find the average of those two numbers as well. So 3 plus, notice I put the negative number in brackets to split up the double signs. So I add them together and divide by 2 to figure out the average. So now -4 plus 2 is -2. 3 minus the 5 is -2 as well. And -2 divided by +2 is -1. So my midpoint of AB is -1, -1. Every single time you get an answer in any stage of this process, you want to check your picture. You want to check your sketch to see if it makes sense. Always, always check the sketch. Always check the sketch. So on my picture, where would the point -1, -1 be? Well, it would be left 1 and down 1. So yeah, that makes a lot of sense. That's approximately where I've drawn my midpoint on my diagram. Very, very important to check. I would encourage you to draw a little check mark, showing me in your work that you've checked that on your picture, because if you get to step 5 or 6 in some of these questions and you haven't verified, if you made a little mistake, you won't catch it, and it'll be really frustrating to have to erase and start over again. So first step done, we have the midpoint. The second thing we need slope, and we need to use that slope to get our equation in the final stage. So we're finding the slope of the median, which means we're going to use the end points of the median. We're going to use point C and point M in our calculation for slope. We know our 2-point slope formula. We also know that we use little m to represent slope for Monty. So the slope of CM, I'm using the two endpoints to specify which slope I'm solving for, is equal to the rise over the run. Now the coordinates of my midpoint are -1, -1, and the coordinates of the endpoint C are 5, 2. So we're going to say 2 minus -1, the y's, make the rise, over 5 minus -1 to calculate the run. Two negatives minus a negative means you're adding the two together. So 2 plus 1 over 5 plus 1 is 3 over 6. That's the slope of CM. Now it's a fractional slope, and it's not written in lowest terms. We always want to make sure that we do write our slope in lowest terms. So we're going to go ahead and we're going to reduce that by dividing both sides by 3. So it becomes 1/2. and that's the slope of CM. Notice I've been putting boxes around the answers just because we're going to have so many slopes and points in our solutions that we want to be able to find what we need when we're using them in the last step. So remember, every time we get an answer, we have to check against our diagram, our graph that we've sketched. So how would I check a slope? Well, the basic way of checking, obviously, is looking at the sign. So is it a positive slope? Is it a negative slope? Is it a 0 or an undefined slope? In this case, your slope is positive. That tells you the line should be going up and to the right. So when you look back at your diagram, the line segment CM or MC does slant up and to the right. So that's a good start. More specifically, the slope of 1 over 2 means the line should go up 1 and over 2 to the right. So we have to look at our line and see if that's what it's doing on our graph. So from point M, do we go up 1 over 2, up 1 over 2? Yeah, approximately we do, up 1 over 2. So we're going to check and make sure it makes sense with our picture. If it does, then we're going to continue on and we're going to use that slope in our final step. So I'm just going to put a check mark showing that I did verify that in my graph, and we're good to go. Finally, we need to find the equation of a median. And remember, we said anytime we're finding an equation, we need a slope and a point. Now the slope we just finished calculating, it's the slope of CM, which is 1/2. And we're going to use that in our equation. The other thing we need is a point. So we have a choice. We can use two different points. We can use the midpoint, or we can use the vertex where our median begins. My advice to you is always use the vertex, because we're going to talk about different types of lines in a triangle that may not go through the midpoint, and it just will help to make sure that the point that you use in your calculation for the equation is going to give you the proper answer. So as a general rule, if you always use the vertex, it'll make life a little easier and it'll leave less chance for error. How do we find an equation of a line? Well, we have a formula now that we talked about yesterday. It's our slope point formula, and it's y equals m bracket x minus p, close your brackets, plus q. So the way that we use this formula is we substitute our slope in for m and the coordinates of our point in for p and q. So in this equation, I'm going to write 1/2 where the m was. I'm going to keep the x the same, and I'm going to use point C, which is 5, 2, as my point PQ. Remember, when you're using the formula, you're going to change the signs for your P. It used to be +5, now I'm going to put -5, and the Q stays the same. When you distribute the 1/2 slope into that bracket, you're going to have to multiply a fraction by a whole number. So y equals 1/2 x stays the same, and we're going to multiply the 1/2 by the -5 over 1. If we were able to reduce, if that were a 4 instead of a 5, we could cancel things out and make life a little easier. But because we can't reduce, we're just going to multiply the top times the top and the bottom times the bottom. The 2 at the end still needs to be added on. It is currently 2 over 1, but you cannot add fractions that don't have the same denominators. So instead of 2 over 1, I'm going to double that fraction to get a common denominator, and I'm going to say plus 4 over 2. So my final equation would be y equals 1/2 x minus 1/2. As always, I'm going to check against my graph. What would this look like? The slope we determined already, but this line would cross the y-axis at -0.5, or -1/2. So looking up at our sketch up here, does the line cross at -1/2 right there? Yeah, it does. If this is 1, this is -1/2, that's pretty good. So our sketch won't be perfect. It won't need to be right on, but even with no ruler, I did manage to find a sketch that gave us an approximate kind of verification that all our answers were correct. So that's how you calculate the equation of a median.